Evaluate the expression 4 cubed. So 4 cubed means 4 times 4 times 4. So the base multiplied it by itself 3 times. So if you're going to simplify this, just multiply it out. You can do this in 2 steps. 4 times 4 is 16. And so now we have 16 times 4, which is 64. So 4 cubed is 64. Let's try the quantity negative 2 raised to the 4th. So the base is negative 2, so it needs to be multiplied by itself 4 times. So negative 2 times negative 2 times negative 2 times negative 2. And if we start multiplying 2 at a time, we get negative 2 times negative 2 is 4. Remember, a negative multiplied by a negative gives us a positive number. And then 4 times negative 2 is negative 8. And finally, negative 8 times negative 2 is a positive 16. So our result is 16. The quantity negative 2 raised to the 4th power is 16. Notice the quantity was negative, it was raised to an even power, and it ended up being a positive value. Because if you have an even number of negatives, you'll end up with a positive. Now let's try this again, only it's slightly different now. Instead of, there are no parentheses, you see, so we have negative 2 to the 4th. So the 4th power only applies to the 2, it does not apply to the negative. Okay, so that can be tricky to realize. If there were parentheses like the last time, then the 4th power would apply to the negative. So we've got a negative, not raised to the 4th, just one negative, times the quantity 2 to the 4th, so 2 multiplied by itself 4 times. And the parentheses have been put here just to further emphasize the fact that the negative is separate from the power, the 2 to the 4th. So 2 times 2 is 4, and 4 times 2 is 8, and finally 8 times 2 is 16, but the negative has stayed with us the entire time, so negative 2 to the 4th is actually negative 16. So this is the same negative that we started with. So make sure you remember the difference between the 2 examples here. It's an important difference. Okay, so now we have a slightly different expression. We have 5 times 3 squared. So the squared power only applies to the 3, not to the 5. So we can write this out. It's 5 times 3 times 3. And we're going to solve this with 2 slightly different methods. So the problem's been written twice here. Right now it looks the same. And so we could start by saying, well, 3 times 3 is 9. Or we could say 5 times 3 is 15. So then we end up with 5 times 9 is 45 in the first example, or first method, and 15 times 3 is 45 in the second method. So what we're doing here is just giving an example of the associative property. It doesn't matter if we multiply the second and third factors first or the first and second factors first, we still get the same results because multiplication is associative. So our result is 45. And let's try a more complex expression. Now we have multiplication, exponents, a division here, we have a fraction, so we have an addition. So remember your order of operations. The first thing we usually look for is parentheses. There are no parentheses. And then we can look at exponents. 2 cubed is 8, and 3 squared is 9. So now there are no more exponents in our expression. Then we want to do any multiplication. 3 times 5 is 15. And moving on, we also have a multiplication now because of the exponent being changed to an 8. We have 3 times 8 is 24. And in the denominator, 9 minus 15 is negative 6. And finally, in the numerator, 30 is the result. 6 plus 24 is 30. Dividing 30 by negative 6, we get negative 5. Negative 5 is our final result. So this expression that looked fairly complex actually reduced to negative 5. If you were going to do this in a calculator, it is a little bit tricky how you want to put everything in. Now, if you look at this calculator, all these button presses here, you'll notice there are parentheses around all the digits for the numerator and parentheses around everything for the denominator. That's very important, so the calculator knows what's the numerator, what's the denominator, and you'll see a division symbol in between because a fraction is really a way of expressing division. So we've got 6 plus 3, then that 3 is multiplied, and we're trying to say 2 to the 3rd power. So your calculator, if you tell it 2, and then press a y to the x key, or you may have an x to the y key, or a caret on your calculator's key, but either way you have some key for exponents. So you have 2, then press that key, and then tell it that the exponent is 3. Then we close parentheses, tell the calculator we're dividing, and as we look at the denominator, we again have a power, there's the division, and then a power, we have 3 squared. Now you could use the y to the x key like we did last time, or most calculators will also have an x squared key because squaring is the most common power that we'll use. So you can press 3, and then there should be an x squared key or some other type of key representing the function of squaring. So press that, and then you subtract, and then 3 times 5, and close parentheses. And the result your calculator will give you is -5. Now if you're not getting a -5, you want to go back and try this again because you're not talking to your calculator correctly. So you want to practice that until you can get this -5 and you know exactly what steps to use. So calculator works well. You also want to know how to do this by hand, which we've done in all of these examples. So you should be ready to go.